Hey everybody, again talking about binomial probability distributions. In the last video we looked at the table, and all the values for that table were calculated using the binomial probability formula. And you saw the limitations on there just with the probability and getting larger and larger values at the end. I mean, we could have all of them work out, but our table would be massive. So one thing that you can use, and for the problems in your homework, is whenever they give you a value of n that is greater than 8, or a probability that you know is not listed in the table, then you need to use the probability distribution formula. And with that, if you look at it, we have factorials, but all factorials are the same multiply. So you're dealing with some multiplication, some division, some exponents, and some subtraction. So within our binomial probability formula, n equals the number of trials. X is the number of successes among those n trials. P is the probability of success, and Q is the probability of failure. If you add P and Q together, success and failure, that's, because we're dealing with the binomial probability distribution, it equals 1. Right? You either have success or failure. So to find Q, you simply say 1 minus P. So we have a problem here. And for this example, we're using the binomial probability formula. When Oompa Loompas are randomly selected, only 43% like chocolate. So if 6 Oompa Loompas are randomly selected, find the probability that at least 4 of them like chocolate. And for your answer, round to 4 decimal places. So as you can see in the stuff that we have here, you cannot use table A1 because my probability is 43%. When you look up in the table, you're not going to have 0.43. You're going to have 0.4. So we need to use the formula. So let me switch this out. And this is what we'll do our work with. Okay? So there's my formula, and I don't like my question having all those words in there. So the first thing that I do is I go through and I find all my critical data. So I've already showed you the 43%, that's P, right? My number of trials, that's going to be N, right? And then find the probability that at least 4 of them, okay? At least 4. Oops, put that at before. So at least 4. And that's not X. The only calculation I have to do is 4 by Q. So I take the information that I need to solve, and the first thing that I do is I write down my formula, and I take my information. So let's see, N was 6, X was at least 4, I hope you remember that, and the probability was 0.43, and then to be able to find the probability of failure, I simply subtract 1, or 0.43 from 1. 0.43. Alright, so now with this problem, because it says at least 4, remember that? Get confused about at least, write it down. I'm ranging between 0 and 6, and somewhere there. So at least 4. I can take at least 4 cookies. How about that? I can eat at least 4 cookies. And 4 would be the minimum, so I can put 4, 5, and 6 right here. So what I'm going to do is I'm going to find probability 4, probability 6, and I'm going to sum them together. So my probability of 3. Now all this is I guess you can just call it plug and chug. I'm going to plug in my values. Again, x turns into 4, 5, and 6, so we're going to work 3 problems. We're going to do probability 4, probability 5, probability 6, and I'm going to plug in all these values up here. So, what I have is, let's see what I do. 6 minus 4 factorial. P is 0.43 to the x is 4, times q is 0.57, to the 6 times 4. And I guess as a refresher, what I'll do is I'm going to write out the factorial just to be able to illustrate it. So, for x equals 4, my specific number of successes for this one, I'm looking for what I have is 6 times 5 times 1. It's 6 factorial. 6 minus 4 is 2 factorial, so 2 times 1, and then 4 factorial is 3 times 3 times 4 times, and then I need to take 0.43. And I got to deal with the lighting, sorry about that. Can you see that okay? Yeah. So I need 0.43 to the 4th power. And then I need 0.57, and 6 minus 4 is 2, so 0.57 for the second time. And then 0.3349. Well, 4321, 4321, those all cancel out. 6 times 5 is 30, divided by 2 is 15. So I need to take 15 and multiply it to these two values. And we'll round to the 5th decimal place, and then add them up, and then we'll round from there. That's a safer bet to do. So, I'm not going to do the calculator on the screen. I will just type it in. Answer. Okay, so what I have here, I'm going to use my approximate symbol since it's not all the way through, but 0.1662. And that is for fixed number trials of 3. So what about fixed number trials of 5? Well, I'm simply going to, that is now my x value. 5 is now x, and I'm going to plug in 5 for all my x's. So I have 6 factorial over 6 minus 5 factorial times 5 factorial. P still stays the same, so 0.43 to the 5th times q, 0.57, 6 minus 5. All that will be left up here is a 6, 5 factorial, cancel them out, and that is just 1, so 1 factorial is 1. So all that's left here is a 6. Times and 0.43 to the 5th. 0.017008443, and I'm going to multiply that by 0.57. Because 6 minus 5 is 1. You put a pressure combination simply there. Now I'm going to multiply the other terms. And again, I will take it out to 5 decimal places. 0.05228.
And I'm rounding up like this one. Slide it up some.
And then,
Is my X my specific number of successes?
being 6. So this one right here, the math of this one is simplistic. Looking at factorials.
Because all of that comes into 1.
0.03, 6, 0.57, to the 6 minus 6, which is 0, and 7. So the probability
Of 6 successes out of 6 tries is simply
0.43 to the 6th power. 0.43 to the 6th. And I'll write it out here. So this one becomes 1. 0.00631 363. And that becomes approximately 0.00632.
now add all 3 of those together.
And the probability at least 4 equals 0.223.
And that is using the binomial probability distribution.
Alright guys, watch your publisher's videos, critically think and structure your homework, and good luck with the rest of your homework.